All right. Hey, welcome to section 4.1, Extremas on Intervals. Let me tell you what's going on. No different from the last couple sections, okay? We've been doing the same exercise over and over again. We've been taking derivatives, and that does not change. Let's talk about our first definition. Extrema on intervals, more specifically, critical values. Okay, and a critical number. A critical number, let f, which is a function, be defined at c. Okay, remember c is usually an x value. And if f prime of c is equal to 0, meaning the derivative is equal to 0, then f, or if f is not differentiable at c, looks like it's undefined at c, then c is a critical number of f. Okay, so that is our definition. And one of the big parts of our definition is looking at extrema, which are really the highest and low points of your function. Okay, and they ask us in these three pictures to find relative maximums, relative minimums, absolute maximums, and absolute minimums for these functions. So let me just call this first one to the left here, f of x. And notice that this actually travels to infinity going to the right, and it travels to negative infinity with respect to y as you move to the left. And as you go from left to right, from more negative values to more positive values, you can see that there is a max at this location. It's where your values increase with respect to y and then eventually decrease. So what I'm going to say here is that there's a relative max. It's not my highest max, okay, because the highest max is over here, okay? That's almost 3, but there's higher values on this curve with respect to f of x, okay? So I'll say a relative max at x equals, and it's somewhere between 0 and 1, and this is just a guess, maybe negative 2/3. Okay, now you'll notice something unusual, and you're like, well, I'm making judgments on this curve in terms of how high and how low it appears, and we found this like kind of a high spot. And notice I didn't write any type of answer with respect to height with this piece of information. Okay, I didn't say what y was. I just said, hey, at x, this is where we have a max. Okay, and it's a relative max. Okay, and that's as far as you need to go. All right, if you look further, okay, as we move in this direction, moving downwards, as you go from left to right, eventually we stop and we start to go upwards again. Okay, there's 1, there's 2. This is a half, okay, about. And I'll say, hey, at x equals a half, it looks like there is a relative minimum. Okay, because for f of x, we decrease and then we increase. Okay. All right, and then if you keep traveling, okay, this is another max. Okay, this is a relative max. It's not the highest one I've got. And I'll say that it looks like it's about at, I don't know, maybe x equals 3/2. And again, that's a guess. Okay. If you look at this, it goes from increasing to decreasing values until you get to this spot. And it looks like that's about, I don't know, maybe x equals 2.5. And someone look at that and say, cool, you found an absolute. And it kind of looks like an absolute because it's lower than the other minimum, okay? However, it's not lower than this curve. This curve actually travels down to negative infinity. So this also is a relative minimum, okay? And that is it. There are no absolute maximums or minimums for this function. All right, so the second one I'm just going to call g of x, and it looks a little bit more elaborate, okay? It has this kind of a funny twist to it. But as you go from the left side, that goes to negative infinity, and then this goes to the right side. And as you travel from left to right, okay, you find that it constantly increases until you get to this spot. You're like, hey, what's going on here? It looks almost horizontal. I don't believe anywhere in that area it decreases, okay? It looks like it still stays at least steady, okay, and it maybe get to a point where it's horizontal. That's called the point of inflection. We'll talk about that later. But in the end, I don't think it decreases anywhere, okay? You eventually get to a position where you're at this location. I'll call this 1, this 2, this 3. And I would say that this is a maximum of some type. And some, again, people want to call this an absolute maximum, but it's not really, okay? And the reason why is because while this has a max of about 4, not quite 4 maybe, at 1, there are other heights that are bigger if you were to keep going along this curve. So this is a relative max at x equals 1. Okay? And then we will decrease until you get to here. This will be a relative min at x equals 2. Okay. And again, it looks like it's low, but again, there are other values here that are smaller than that. Okay, so that's as far as it'll go down. And that's all you do. Okay. All right, this last one of h of x. Okay, and if you look at this, again, this from the left-hand side goes to positive infinity, and so does the right side. It also goes to positive infinity. So you can kind of eyeball this and say it looks like there's some max and mins on this curve. Okay, and if I do the one most to the right, okay, this definitely looks like a min at 2. So a relative min at x equals 2. Okay, and then as you move in this direction, more towards the negative direction in terms of x, okay, that looks like a max. So that is a relative max at x equals 0. Okay. And if you travel further, this is a minimum too, and you'll notice that there is no place on this function h of x where it travels lower than this location. Okay, so I'm going to kind of guess where I think this is, and it's between the 3 and the 4. So maybe 3.5 x equals negative 3.5. That is a relative min. Sorry, not a relative min, an absolute min. I was going to scratch this relative out, but I think it deserves something better. Okay, let me erase that part. Okay, and because that is the only absolute on this slide, I'm going to make it look like royalty. We'll call this a absolute min. Okay, I'll abbreviate it. So, all right, and that's how those look. Okay, in time, which means on the next slide, I'm going to put some justifications as to why they're maxes and mins, other than just eyeballing it. Okay, it's not always that we're going to have a picture where we can answer these questions just by looking at it visually. Okay, sometimes, like we'll see on the next slide, you're going to have equations. You're not always going to know exactly what they look like. Okay. All right, so number 4 looks like this. It says find the extrema. And extrema usually means with maxes and mins, and I want it on this interval. Okay, so this is a boundary from -1 to 2. And the first thing I'm going to do for both of these, okay, is the same procedure. Maxes and mins occur when our horizontal tangent lines are 0, okay, or have a 0 slope. So I'm going to take my f prime of x here, and that will give me 6x. Remember, the derivative of 6 is 0. And then you set this equal to 0. And so x is 0. Okay, now here's what I'm going to do. Draw a little tree chart. I'm going to put x here. I'm going to put f prime of x in the output column. Okay, so not f of x, f prime of x. I'll put 0 somewhere in the middle. And then what I know is when I plug in 0 for this x, I'm going to get an f prime that is also 0. And then I'm going to pick some things around it. Okay, so something a little bit lower than 0 is -1. Something a little bit higher than 0 is 1. And if you input those into my derivative function, okay, which is -1 and 1, take a look here. When x equals 1, 6 times 1 is 6. When x equals -1, 6 times -1 is -6. Okay, and what does this mean? Well, remember, f prime of x is slopes. Okay, so what I'm saying is that your slopes are going from negative values, then hitting 0, and then going to positive values. Okay, which means this is a minimum. Okay, and so I'm going to say there, I'm going to write this sentence, is a minimum at x equals 0, since there, say, how about there? How about the function? Let's change that, sorry, erase. Okay, the function f prime of x moves from negative to positive values. Okay, at x equals 1. Okay, now disclaimers like, dang, do I have to write all that? You bet you do. Okay, and even something to be a little bit more careful about, I'm going to put this in red. Okay, is that you identify your function. Make sure you say f prime of x. Don't say f prime of x is it. Okay, don't call it it because it moves. I don't know what that means. Okay, that's an ugly it, which means don't write it. Okay, when you say it, I don't know if that's the original function. Okay, I don't know if that's the derivative function. It can mean 1,000 different things. Okay, so don't say it. Okay, and second, when I move from negative to positive values, don't write negative as this. Okay, or positive like that. Okay, and the reason why is this could mean negative. Okay, it looks like a negative sign. It could mean subtract. Okay, could mean that you're decreasing. Okay, it could mean that it could mean a lot of things. Okay, so make sure you write the actual word to describe what you're talking about because those symbols have some ambiguity to it. Okay. All right. So, are we done? No, I'm sorry. There's more to do. Okay. And here's what we're going to do. I'm going to go back to the original function. I'm going to call this x. I'm going to call this f of x. And I'm going to put this critical value here, 0. Okay. And I'm also going to put the endpoints, -1 and 2. And since 0 is in between them, okay, we're just going to test these into my original function. Okay. And so 0 is easy. You plug that in, you get -6. When you plug in -1 here, -1 squared is 1, times 3 is 3, minus 6 is -3. And when you plug in 2, you get 6. Okay, and you're going to look for the outputs that are the biggest and the smallest. Okay, and since that provided the biggest output, I'll say there is an absolute max at x equals 2. Okay, and then if I look at this, the lowest output for an f of x was at -6, and that's when x was 0. So I'll call that a min, and an absolute min okay, at x equals 0. Okay, and then you are done. It's not enough to just kind of like, hey, just write some things down, write a chart out, and then kind of points and say, hey, max min, write a good sentence for each. Okay, you're gonna have to communicate your thoughts well in this type of mature math class. Okay, so write it like this, write this part down too, avoid shortcuts. Okay, make sure it looks clean and neat. All right, so here's my roadblock for this bigger problem. I probably don't need all that stuff, all that room, but just in case, let me do this in green as well. And I'm going to treat this the same way. I'm going to find my derivative. So let's take the derivative of g of x, which is g prime of x. And that gives me 8x cubed minus 32x. And we will set this equal to 0. Okay, so 8x cubed minus 32x. Let's pull out an x. Okay, and that gives me 8x squared minus 32. And we will set some things equal to 0. Okay, so here that gives you x equals 0. Let me add that 32 over. Okay, and that gives me 8x squared divided by 8. X squared equals 4, which means x equals plus or minus 2. Darn it. All right, so what does this mean? Well, What it means is I got to do a chart like I did over here. The only difference is, like the one over here on the left side, I've got 3 critical values. I've got 0, I've got +2, and -2. So I'm going to make myself some room. Here is x. Here is g prime of x. And I've got 3 values. I got -2. I'm going to leave some space. I got 0. And I have leave some space, and I've got 2. And my g of x, g prime of x's are all going to have zeros behind it. Okay. And let me use a different color here. How about, I guess, red. Okay, let me put some numbers that are in between these. How nice that I could probably put a -1 and a +1 there. And how about a -3 and a +3? All right, now you can put these numbers here in any order, and with respect to do which one you want first. So sometimes I like to do it in the most factored form, but it's totally up to you. Like you can do it like this. You could do it like this, put an x here, pull out your 8, which is really not significant, and it becomes x -2 and x +2. And you're really just looking to see whether things give you positive or negative values. But as you plug them in, like I'll start with 1. If you plug in 1 here, you get, it looks like -24. Okay, if you plug in -1, be careful of your negative signs as you put these in. You're actually going to get a +24. When you plug in 3, and I'll start with this more positive one, I think you get a really big number. I think you get, I got 180, but let's check. 8 times 3 cubed. Okay, -32 times 3. Ooh, messed up. So if I insert a minus sign in there. 120. So it wasn't 180, but I checked. Okay, and if actually you do the negative, you would get this one, -120. Goodness. All right, so, well, what does that mean? Well, let's take a look. At -2, we go from negative values to positive values for g prime of x. So at x equals -2, we move from negative values, okay, to positive values. Okay, for f prime of x, sorry, g prime of x. Okay, at x equals 0, we do the reverse. We move, okay, from positive values to negative values. For g prime of x. Okay, and at x equals -2, okay, it's the same thing as above, okay? So what I'm going to do is I'm going to cheat a little bit and just write that right here. X equals -2. A little block there, because the definition is still the same, okay? And what does that mean? Well, it means that when you move from negative values to positive values for g prime of x, okay, notice I wrote the function there, that means you're going to have a minimum, okay? So some type of minimum, and this, of course, will be some type of maximum when you go from, excuse me, negative values to, sorry, positive values to negative values. That means you're going to have a max. Cool. All right. So again, this -2 I put above because it had the same type of identification. So here's what I'm going to do. Here's x. Here's g of x. Don't put the prime there, just the regular g of x. It goes from -1 to 5. In which of these 3 values, 2, -2, and 0, fall in between these two, okay, these 2 numbers? And you can see that 2 does, for sure, and 0 does, that does for sure. And -2, while that was an important part of an extrema, that's not part of our interval, so I don't have to care about -2, so I'm going to slightly scratch that out. And what I'm going to do is I'm going to plug in all these values into my original g of x function. Okay, so when you do that, first of all, 0 is easy. I'm going to do that one first. Okay, you get 0. And let's see, I think when you plug in 5, you get a big number. You get 850. Okay, when you plug in 2, I think you get negative 32. Okay, when you plug in 1, that's negative. It just makes it positive here, makes it positive here. You're just going to get 2 minus 16. Should be negative 14. Okay, so if I look at my largest value at x equals 5, and all I'm going to write is 5. I'm not going to write the 850. I can see that that's the highest number. We have an absolute max for this function in interval. Okay. And let's see. The lowest value I have is at 2. So at x equals 2, I have an absolute minimum. And that's about all I need to say. Okay. Are there some relative ones? It looks like at 0 there was a relative max, so you could say that if you want. At x equals 0, there is a relative max. And then we are done. Okay. All right, let's take a look at 2 more. I know that's a lot of writing, but that's how these go. All right. And my face is covering part of this. Look at that. I'm going to miss that whole piece. All right, now this one here, kind of a funky derivative. All right, so let's start off with this h prime of x. I'll put it down here. H prime of x is equal to derivative of 4x is 4. And the derivative of 6x to the third, 2/3, is going to be 12 over 3, which is 4. Okay. X to the, now you got to subtract this. 2/3 minus 1 is negative 1/3. Okay, so let's see if that makes sense. Yeah, 2/3 times 6 is 4, but then you got to subtract 1 of that. That's negative 1/3. And before I simplify that, let's just set equal to 0. It may simplify as we work through this. Let's add the 4x to the 1/3 to this side. Let us divide by 4. Oh, that's negative 1/3, sorry. Gives you x to the 1/3, which is negative equals 1, which is 1 over x to the 1/3, which is equal to 1. Put a 1 underneath it if you want, and when you flip it, it just gives you the same thing. Okay, so basically, you got x equals 1 here. All right, so first part, here's your x. Here is your h prime of x, and there's only one critical value. That's kind of cool, okay? And let's see, it's at x equals 1. Why did I do that? Okay, so x equals 1. And I know when I plug in 1 to this derivative, I'll get a 0. And I got to pick something a little bit bigger than that and something a little bit smaller. So let's think of something. How about 0 and 2? All right, and so when I plug in 0 to this, something crazy happens. If you think about it, you have 4 minus 4 over x to the 1/3. That's really what this is. And you can't really put 0 in your denominator. Okay, so 0 is actually going to be where it is undefined. Okay, so that, interestingly enough, is going to be another critical value. So let me change that to a dark blue. Okay, because remember what a critical value is. It's where your derivative is 0 or where it's undefined. Okay, and that addresses this piece. Okay, So what does that mean? It means you got to pick a number that is less than 0, like, but also bigger than -1. So let's do this. Let's call it -1/2. Like, wow, this problem all of a sudden got ugly. -1/2. Okay, and then you also have to pick a number between 0 and 1, like 1/2. Okay, and what does 0 do? It just gives me an undefined, but we will address it. Okay. All right, so let's do this. Let's find all the other items, okay? And there are 3 of them that you can't barely see this one here. And in order for me to make this work, I think it's easier just to put this derivative on my calculator. So in another function here, I will, of y, I'll put this in maybe y2. Okay, so let's see, it's 4 minus 4x to the power of -1 divided by 3. And so I will delete some other things. Okay, and I think that is good. Oh, I just lost it. Cool. All right, so that is my new y. And so I'll do an alpha trace again. And I'll just plug in these values. When I plug in -0.5, I get a big number here. I get 9.0397. Okay, if I did that right. Yep. Okay, and I'll do the same thing for +1/2. And this gives me -1.0397. And then the last thing is 2. 0.825. Okay, now notice for each of these, I go at least 3 place values to the right of the decimal. Okay, that is a minimum that you need to do. Okay, so maxes and mins between this two. You'll notice that this value is -1/2, and these are all slopes. So nothing's really going on between these two. It's undefined here, so you can't really make a statement. Okay. Further, it looks like at 1, looks like you're going from negatives to positives. That's a 0.825. So here's what I want to say. At x equals 1, h prime of x, which is your derivative function, moves from, we'll say, negative values okay, to positive values. Okay, and so if you go from negative values to positive values for your derivative function, that means that you have a minimum of some type. Okay, we'll look at that more closely in a second. Okay. All right, so a lot of things to look at. Here is x. Let's go back to this h of x. Okay, and I've still got 0 and 1. Okay, those are still in between these, and then I've got -1 and +3. Okay, so again, these are kind of boundaries that let me know what I needed to do. And I can't say here, I know you're looking at that and saying, what's going on here? Is there a change in max and min? And not necessarily, okay? Even though you're going from positives to negatives, the derivative does not really exist here. Could be something. I don't know, let me take a look at it real quick. Let's just check to make sure. 4. So I'm putting this in my graphing calculator just to kind of verify. And that's what's nice about graphing calculators. If you just want to make sure, okay, you can check on things. Okay, and you actually may have something here. If you go from positive values to negative values, okay, increasing to decreasing values for h prime of x, it may also have an item here. So at x equals 0, this will actually give you a good picture. Here's what we'll say. H prime of x moves from, we'll say, positive values. I'll just say positive and negative values. Okay, which means it could be a max. That could be. We'll take a look. Okay, so we will move all three of these, okay, four of these into my original function, 4x minus 6x to the 2/3. And it gives you a really cool picture if you graph it. I'll let you do that if you want. But to find these super quick, I'll plug in 0, of course. That will give me just 0. I'll plug in 1, and 1 just gives me 4 minus 6, which is negative 2. I'll plug in negative 1, which gives me a positive 2. And that 3 is going to be something ugly. So 4 and then parentheses 3 minus 6 times 3 to the power of 2/3. Good. And you get a negative 0.48. All right, so amongst these, the highest number I have is a 2. So there's an absolute max at x equals 2. And the lowest one here is a 1. So we have an absolute minimum at x equals 1. Sorry, I wrote this bad. Absolute max gives you a value too. It should be at x equals negative 1. My apologies. That is a huge typical error that a lot of people make. They write it in terms of their y values because that really indicates really a height, but in the end, it's not that. It's really the x values that we identify with. X equals negative 1. And the only other one I may want to consider is the where I have a 0. And at 0, we said this may be a minimum. So this could be a relative minimum at x equals 0, which we identified. Sorry, it's a max. Okay, right here. So I'm sorry, at x equals 0. You said it was a max. My bad, but we got it fixed. Okay. Some people may say this and say, how come we didn't talk about the 3? Okay. And really the 3, it's kind of like you can kind of look at it and say, decide whether you're increasing or decreasing there. And it may show that it's increasing to that point. But usually when we talk about something being a max or a min and it having it be an endpoint, sometimes you like to say it's going from increasing to decreasing or decreasing to increasing. And that doesn't really happen here. Okay. So it's not like the highest point or the lowest point. It becomes kind of like a higher point for that respective area, but it never goes to a decreasing perspective after that because that is the end. Okay. Whereas when you're talking about absolutes, if they happen to be an absolute, you usually go with it. Okay. You can identify it that way. All right, last one. It is true. This is the last one. The next slide is just your homework page. But you can see how much work is involved. It's a lot of perspective here, and a lot of scripting to make sure that you're communicating good thoughts. Okay. All right. J of x equals 2 sine of x minus cosine squared x. All right. So j prime of x, okay, is equal to, so the derivative of sine is cosine. Okay. Now this is really cosine of x squared. Okay, so when you take the derivative of this is a power rule. 2 times the cosine of x, all to the power of 1. Okay, and then you got to chain rule it. Okay, so the derivative of cosine is negative sine. Okay, and you want to probably move this negative to the front. So you will get 2 cosine x, and a subtract and a negative will give you an addition. Okay. and then we'll set it equal to 0, which means you will have to factor. So this will be 2 cosine x, and then this gives you 1 plus the sine of x. Okay. And you will set each one equal to 0. Okay, and so divide by 2. And ask yourself, where is cosine of x equal to 0 between 0 and 2 pi? And think about cosine looks like this. Where is it 0? Well, at pi over 2 and 3 pi over 2. And conversely, where is the second piece? Subtract the 1 on both sides. Where is the sine of x equal to -1? Well, here's my sine curve. That is not my sine curve, that's my cosine curve. New color. Here's my sine curve. And where is it equal to -1? Well, right here. And if this goes to 2 pi, this is 3 pi over 2. Okay, which is cool, but it's already identified over here, so I don't have to do it twice. That's kind of nice. All right, so here's x. Here is j prime of x. Okay, and I've got 2 points. I've got pi over 2, and I've got 3 pi over 2. And I got to find something that fits in between it. I know those both give me zeros. And I will use, I'll set black. Okay, so pick something in between like pi. Okay, pick something a little bit lower than that. So how about this? I'll just say pi over 4. I'm always afraid to pick the boundaries, okay? Especially when you choose 0 here. 0 is the same as 2 pi, and you don't want the same boundary for each, even though it may work. 3 pi over 2. How about 7 pi over 4? Okay, and that's less than 2 pi as well. So, all right, and then you got to plug it into one of these two. So you can plug it into the first guy, or you can plug it into one of these. Totally up to you. All right, and so I'll start with this first. I'll start with pi because I think pi is easiest. The cosine of pi. Well, here's your cosine curve. Cosine of pi is -1. And when you plug in pi here, the sine of pi is 0, which is times 1. So that gives you -1. Pi over 4, okay? Pi over 4, cosine of pi over 4 is rad 2 over 2. So 2 times rad 2 over 2. That's this first part. Okay. And then 1 plus, this is also rad 2 over 2. Okay, and all I know is this. This gives you rad 2 times 1 plus rad 2 over 2. Okay, and the idea is this, it's positive. It doesn't really matter what it is, you just know it's positive. I could write it out, but that is enough, okay? And the same thing with 7 pi over 4. When you plug that into the first guy, all right, now the cosine of 7 pi over 4, this is still a pi over 4, which is going to be some form of rad 2 over 2. Now 7 pi over 4 with respect to cosine is over here. Okay, if this is 3 pi over 2 and this is 2 pi, okay, 7 pi over here is in the positive direction. So I know that that is positive rad 2. And then 1 plus, and then the sign of that is over here. So that's going to be minus rad 2 over 2. Okay, nevertheless, 1 is bigger than this. So this whole piece right here is positive. And times a positive times another positive is going to be a positive. Okay, and you can leave it like that. You don't have to simplify it, just as long as we know the direction. Okay. Don't skip all this right again, just put positive because that's not good enough. And what does that mean? Well, it means that pi over 2, we go from positive slopes to negative slopes, which means you have a max. Okay, and it means here when you go from negatives to positives, that's a min. So add 3 pi over 2, I'm writing this kind of small. Okay, you have a min. Okay, and why is this a max? Well, again, because you go for f prime of x, sorry, not f, j prime of x. Okay, and that's a prime. It moves from, and we'll say from positive to negative values. Notice I'm not shortcutting this. I would love to abbreviate more, but it's not good to. Okay, positive, negative values, that's a long values, U, E, S. Okay. And then at 3 pi over 2, okay, we said that was a min. This one's going to be a max. Sorry, a minimum. There we go, there's our max. And here's our min. Okay, because j prime of x, make sure you put that prime in there, moves from negative to positive values. Okay, and again, I identified j prime of x. Okay, so. All right, so there we go. And what we're gonna do is we're gonna take this and do the last piece of this assignment. Sorry that is so crooked. It's the best my pen can do. We have x, and we're just gonna do j of x. We're gonna put 0 here. We're gonna put 2 pi here. Here's the cool thing, you're gonna get the same answer for each of these, so that'll be nice. And we'll have pi over 2. And we'll have 3 pi over 2. Okay, so when I plug in 0 for this sign, I get 0. And remember, this is just the cosine of x squared. So when you plug in 0 for this, you're just going to get 1. And so 0 minus 1 squared is -1. And that'll be the same for this guy as well. Okay, and all that means is this is balanced on each side from the top to the bottom. It's going to have the same finishing y spots. Okay. All right, now if you plug in pi over 2, the sine of pi over 2 is 1. Okay, and then the cosine of pi over 2 is 0, so that's going to give you 2. And if you try 3 pi over 2, the sine of 3 pi over 2 is -1. Okay, and 3 pi over 2 here is 0. Okay, and so what does that mean? Again, at pi over 2, you're going to have an absolute max. Okay, as you've described down here, you don't have to write anything further because you've already identified why it's a max. And down here, you will have an absolute min. Okay. These, I'm not going to call those relatives. I'm one that if it's some type of relative max or min, you have to go from increasing to decreasing or vice versa. And I think that's going to be okay. All right. That's all I have for you. I say that's all. There's only 7 questions, but that's a lot, okay? You can't answer one of these questions all on one little line of your sheet of paper, which some of you'd like to do. Like you like to minimize your space. This isn't the section to handle that, okay? And actually the whole chapter is kind of elaborate like this. So some of you do a great job. Some of you try to conserve space. The more you try to conserve space, the harder it is to read your work. And that's bad for you because that's where more silly mistakes happen, okay? So be aware of that, okay? And if you have any questions, you let me know. I hope you have a great day. There's your assignment, okay? Not every one of these means do the entire process. Sometimes they'll just look at pictures like you saw on that first slide. Sometimes you'll have to just find the max and mins, okay, without actually finding the absolutes, okay? Take derivative, set them equal to 0, but there you go. All right, have a great day.